Hey, happy day after spring break, and welcome to the video on the pre-calculus progress check review. So what I'm going to be doing today is going through a few questions, showing you guys how to solve these problems, give you some ideas. A couple things I really want you to do is maybe screenshot the chart that we used, screenshot the unit circle. We're going to be using those to help us solve the problem, and make sure that you have Desmos open in a new window, or that you have the Desmos app on your phone, because there's a couple of questions that we're going to have to use to really help us with that. So that being said, let's take a look at some questions here, and we're going to do what we can. And let me just share my screen. So to start off with, what we have here is the unit circle. Okay, so the unit circle, hopefully you all remember, we got two parts or a bunch of parts here, but all our points are cosine. Apologize here, the pen's not working very well. Cosine, sine, okay? So cosine and sine, that's what all of our points are, and we have to be aware of that. Okay, so for example, if I'm looking at 30 degrees here, 30 degrees is also pi over 6 radians. The cosine's √3/2, the sine is 1/2. So we can use the unit circle to help us. That being said, we also have a chart, which has the other ones. It has a secant, cosecant, and cotangent. So if I want 30 degrees and the sine, you can see that it is equal to 1/2. And again, not saying you have to use these, but it might be a little bit of a help when we are using these to solve these problems. So let's do a couple of examples as we go through. So the first question is asking us, hey, what is the cosine of 5 pi over 4? Well, 5 pi over 4 is a radian. So I'm going to go around my unit circle till I'm at 5 pi over 4. Boom. There's my 5 pi over 4. And I know on my unit circle, everything is at, I apologize why this is not working. Doesn't make sense to me. Let me plug everything in. This is at cosine and sine. Wow. Weird. Cosine and sine. Okay. So 5 pi over 4, we're looking at the cosine. Cosine is that first number. So this is going to equal negative. Man, pen's not working very well. Negative square root of 2 over 2. So we want to be aware of that as we go through here, and make sure everything is good. Apologize for the writing. Not much I can do about it. Here's a different type of question. We're given a lot of information. We're given cosine is equal to 3 over 5, sine's equal to 4 over 5, determine tangent. Well, we need to know a couple things. One of the important ones was SOHCAHTOA. Okay? So SOHCAHTOA, that means sine is opposite over hypotenuse. So opposite over hypotenuse. Opposite side is straight across. This is a 4. My hypotenuse is a 5. Cosine is adjacent over hypotenuse. So my adjacent side is going to be 3. So this is a 3 here. And then finally, we're asked to find tan theta. Ooh. Boom, tan theta is equal to, tangent is opposite over adjacent. Opposite side is 4, adjacent side is 3. That's our answer for thirds. Again, fairly straightforward, pretty easy question. Now, we have this, again, you might want to screenshot it. It's one of the identities we learned, okay? We have sine of pi minus theta is equal to positive sine. Cosine of pi minus theta is equal to negative cosine. And tangent of pi minus theta is equal to negative tan of theta. So we're given that theta is equal to pi over 6. We want to determine what the pi minus theta is. So first thing I'm going to do is look at, okay, where's my pi over 6 is right here, and my sine is 1/2. So nice, pretty easy question. We get 1/2. Woo. Okay, now what is the sine of pi minus theta? Well, this we can rewrite as the sine of pi minus pi. What is going on? I apologize. Let me see what I can do here. Pi, where's my pen? Minus pi over 6. Okay, now I'm using the mouse, okay? That is going to be the same as the sine of pi over 6, which is the same as, boom, which is equal to 1/2, okay? So, boom, we're good. And actually, if you look at over here, sine of 5 pi over 6, right here, sine of 5 pi over 6 is also 1/2. But if you know this identity, it just makes things a little bit easier, okay? Because we know sine of pi minus theta is equal to sine theta. It's the same answer. So what do we notice about our answers? They're exactly the same. Determine the following information about this graph. F of x equals cosine x. What do we know about the domain? So our domain is all of our x values. So this thing here, it looks like it's going on forever and ever and ever. So it's going to go from negative infinity to positive infinity. My range is the smallest number, boom, which is here, to the biggest number. The range, I'm going to use square brackets there, go from -1 to 1, because those are included, okay? Notice it's parentheses when we got the infinities, but brackets when we got the range. And our period, a period refers to how long does this thing take to repeat itself? Well, we're starting here at 0. I keep coming along. When am I back out at 0, 1? When is my y value equal to 1 again? Boom, right there. So my y value is equal to 1. So my period is 2 pi. That means this thing repeats every 2 pi. Another question. This one here is a little bit more challenging, okay? Antonio's got to make sure you read the question in totality. Antonio's toy boat is bobbing up and down water. The height of the boat is in centimeters. From the bottom of the mast can be modeled from the graph below. Determine the equation that models the height of the boat. Well, one of these things that I really, really like to do with this is I like to draw something called the midline. And the midline is the line that is exactly 1/2 of the way through, okay? So that helps me calculate the amplitude. And the amplitude is how high is this thing? How high does it go? What is the amplitude? Oh, amplitude. Come on, Ben, work. Is how many units up from the midline? And we count 1, 2, 3 units. So our amplitude is equal to 3. Here's our I prefer to use the cosine all the time, okay, because the cosine always starts at the top and then goes down. We use the sine if it starts in the middle and then goes up. So I'm going to use the sine here, okay, or sorry, the cosine. So let's get rid of this thing. We don't need that. So we're going to use the cosine, and then B helps us with the period, okay? Now to find, we know what the period is, but we got to figure out what B is. Oh, no, we don't know what the period is. The period is when this thing repeats itself. So here we are at 2, and then it's over here at 2 again. And how many units do we come across? 1, 2. So our period is 3. So our period is equal to 3. So we want to find out what B is, okay? So we have 3 equals 2 pi over B. Now, doing some math, we can say B is equal to 2 pi over 3. So that's my B. Boom, boom. And then the final thing is the D. So D represents how far this midline is above or below the x-axis. Well, we can see the midline here is down 1 unit. So our D is -1. So if we come up now with an equation, we're going to say H of T, that is absolutely terrible. H of, ooh, boom. I don't know what's going on with my pen. I have to use the mouse. So H of T equals, and then my A is equal to 3 cosine, and then my B is equal to 2 pi over 3 T, not X this time, it's T. So it's 2 pi over 3T, close those parentheses, and then -1. This is our equation here. Beautiful. Okay. All of these steps are necessary. And my biggest hint for you is to draw that midline. Now, this question looks terrible. Okay. It looks horrible. So what we were going to do here is we want to use our calculators, and I'm going to suggest that you guys use Desmos. That's why I said to pull it up, okay? And we're going to use Desmos, and we want to find, okay, here's our equation, and we want to find at what time is the depth of the water first 6 feet deep. That's going to be sort of the important thing here. So I'm going to look at Desmos. Here's my beautiful Desmos. I want to make sure that I'm in radians because my equation here is in radians. Okay, so I want to make sure I'm in radians, and it looks like T equals 0. So I'm going to start my x-axis. I want to be able to see some stuff. So I'm going to say -2, and let's say like to 12 noon. Okay, so that way we're going by 1 hour increments. And I'm not sure about the y values. The y values, let's like make them from -10 to 10. Okay, so we can do that, and we have now we got our scales pretty good, and we want to write in our equation. We got y equals -3 cosine, and then we're writing pi. So we're going to do a space pi hit the division sign, that's just below the question mark, divided by 4, and then we're doing x, x, okay, because we're choosing x here, and it's a plus 6. So there is our equation. Right there, boom, boom, boom. There is our equation. I want to zoom in. Can I zoom out? Yeah, let's zoom out a little bit. So here's our equation, this beautiful graph. Now, our question is asking us, when is it 6 feet deep? So what I'm going to do is create another equation. I'm going to say y equals 6. Boom, that's it. Oh, I need a small y equals 6. And we get this line coming around. So we're looking for where on Desmos, bum, 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 it is first 6 feet deep. And it is right at this point here at 2 hours, or for our context, it's going to be at 2 a.m. So we want to let me copy and paste this into here, and we can see, boom, this here, these are hours along here. So boom, these are hours down here, right there, and this is feet, or the depth of the water is there, and we're good to go. Okay, so use Desmos to help you. It can't hurt. And then final one here, we got to use restrictions. Okay, so we want to make this thing 1-to-1. So our domain of sine x, the domain of sine x, to make it 1-to-1, is going to go from negative pi to pi. And the range is from -1 to 1. And again, I'm going to do these, boom, and I'm going to include these as well in my domain and range. Now, to do the inverse, all we do is flip these things, okay? We're going to flip these. So this becomes -1 to 1. This here is negative pi to pi. Okay, I thank all of you for watching. Best of luck on the progress check. Ask your teachers if you have any questions. We are here to support you. Take care of yourself, guys. Be safe, and we'll see you on Thursday. Bye for now.